Alright guys, we are solving systems of equations using elimination. And the way you can tell that you want to use elimination is if both of your equations are in standard form. That's ax plus by equals c, where a, b, and c are all numbers. So if both of your equations look like this, so when you stack them on top of each other, they line up really nicely, that's when you want to use elimination to solve your system. The way that we use elimination is we decide on a variable to eliminate. It can be x or y, it doesn't matter. And then if needed, we multiply one or both, sometimes both, equations so that you have equal but opposite coefficients. Now I put that in quotes because by definition, things that do not have the same sign, which is what I mean by opposite, is one is positive and one's negative. Things that do not have the same sign are not equal by definition. That doesn't make sense. But that's my description for the coefficient. If you have a positive 2 on x, then you want your other x to have a negative 2. So you want the coefficient to be the same, but the signs to be different. Then what you do is you add the equations together. Once you do that, you should get one variable, and then you're going to solve for the remaining variable, whatever you have left. After you've solved for that variable, you're going to plug the numeric solution from step 4 into one of your original equations and solve for the other value. So I'm going to go ahead and solve one of these, and after I solve one of these, I want you to pause the video and try the others on your own, but I'll solve number 1 as an example. So I'm looking at this, and I see that they're both in standard form, ax plus by equals c, and that's really useful for me. And so I need to decide which variable to eliminate. I'm going to eliminate x, and the reason I'm going to eliminate x is that I have 2x in both equations. Now, if I were to add them together right now, I'd get 4x, and that's not what I want. In order to eliminate them, I need to make one of them negative. It does not matter which one you make negative. I'm going to make the bottom equation negative. So I'm going to multiply by -1. And I'm going to rewrite my system after that multiplication. So my system is 2x plus 6y is equal to 17, and then I multiply this as negative 2x plus 10y is equal to -9. And then I'm going to add these together. And when I do that, what I get is 0x plus 16y is equal to 8. And what that is that's just 16y is equal to 8. And I solve for this by dividing both sides by 16. And when I do that, I get y is equal to 8 over 16, which is a fraction. That's okay. Fractions are our friends and sometimes our food. Not to freak out. 8 over 16 is just 1/2, right? 8 is half of 16. So our value for y is 1/2. It's totally fine. It's going to work out nicely. So what I do is I take that y value and I plug it into one of my 2 original equations. And so I'm going to just choose the top equation because why not? And so this is 2x plus 6y is equal to 17. And I know that y is 1/2. And so this becomes 2x plus 6 times 1/2 is equal to 17. 6 times 1/2, 6 times 1/2 is 3. That's half of 6, which is 3. So it's 2x plus 3 is equal to 17. Subtract 3 from both sides, and you get 2x is equal to 14. Divide both sides by 2. You get x is equal to 7. And so my solution to this system is the 0.7 That's my solution. Alright guys, pause the video and try 2, 3, and 4 on your own, and then come back when you're done and check your answers. Okay, so here we are with number 2. I've got 4x and -3x, and -2y and 4y. So I have to decide on a variable to cancel. I'm looking at this, and I can easily make this -2 into a -4, which will cancel with the y. And so I'm going to do that. I'm going to do that by multiplying the top equation by 2. I'm going to rewrite my whole system. So this is, I'm multiplying by 2. It's 8x. I almost wrote 4, guys. That's how easy these mistakes are to make, so please be careful when you're doing this. 2 times negative 2y is negative 4y is equal to negative 32. Then I've got negative 3x plus 4y is equal to 12. And so I add those two equations together, and when I do that, I get 5x plus 0y is equal to negative 20. And that's just 5x is equal to negative 20. So I'm solving for x, and I'm going to divide by 5. I get x is equal to negative 4. Now what I'm going to do is I'm going to take that negative 4 and plug it into one of my two original equations. So I'll just use the top equation because why not? And so this is 4x minus 2y is equal to negative 16. I know that x is negative 4. And so this is 4 times negative 4 minus 2y is equal to negative 16. This is negative 16 minus 2y is equal to negative 16. Add 16 to both sides. I get negative 2y is equal to 0. Divide by negative 2. And I get y is equal to 0. It's totally fine to have this happen. We still have a variable, and you're allowed to have a variable equal to 0. So just don't freak out if you get, 2y is equal to 0. Just keep solving. And so the solution to this system is negative 4, 0. All right, guys. Looking at number 3, I need to eliminate one of these variables, and I notice that I have 3x here and 6x here. I can easily make that 3x into a negative 6x, and so I'm going to do that. I'm going to do that by multiplying this top equation by negative 2. And I'm going to rewrite my system when I do that. So this is negative 6x plus 8y is equal to 20. And this is 6x plus 3y is equal to negative 42. I'm going to add those equations together, and I get 0x plus 11y is equal to negative 22. And now I have just a one variable equation that I can solve. 11y is equal to negative 22. Divide both sides by 11. And I get y is equal to negative 2. And what I'm going to do now is I'm going to plug that into one of my two original equations. I'll use the second equation this time. So we've got 6x plus 3y is equal to negative 42. And we know that y is negative 2. And so this is 6x plus 3 times negative 2 is equal to negative 42. 6x minus 6 is equal to negative 42. Add 6 to both sides, and we get 6x is equal to negative 36. Divide both sides by 6. We get x is equal to negative 6. And so my solution here, is the point, negative 6, negative 2. All right, on to number 4. I'm looking at this, and I see that both of these variables will cancel out easily. We have done 2 x's, so we'll do y this time. Now these y's have the same sign, so I need to change one of their signs. I'm going to multiply this top by negative 2. And what I get here is negative 8x plus 6y is equal to negative 20. And 8x minus 6y is equal to positive 20. I'm going to add these two equations together. And when I do that, I get 0x plus 0y is equal to 0. And so what I've got is 0 is equal to 0. Everything is gone. And if you are worried by this, please go back and watch the types of systems video that I made, because we talk about this happening. But what this means is that this is a true statement. First of all, it's a true statement. It's true, 0 is 0, and it means that there are an infinite number of solutions. So again, if you are confused by this or this bothers you, please go back and watch the video on the types of systems, because we discussed this in